上面一点点，不能上下吗？
可以，就这样。
不行，
啊，这样是不是 ？OK 了，
啊，对，可以。那现在是好的。
那 Teams 也是好的，是吧？
对。
So it's streamed. It's streamed on a like dedicated channel on YouTube, or how is it streamed?
We are not running YouTube, so we have two channels. One is just the Teams, so we have a kind of Teams meeting. So we send this Teams meeting link to our editorial board member and authors. A second channel is actually WeChat channel. You know, WeChat, they have, WeChat channel is like more popular among Chinese audience.
Right.
Yeah. So you can sit here now, so we have the slides and the mouse.
Can we maybe turn up the air conditioner a bit? It's getting hot in here.
I see, yeah, that's true.
行，有的。
有的。
Thank you.
How was your presentation yesterday? It was good?
Excellent, yeah. I think it went well.
Yeah, yesterday's the audience is undergraduate and graduate student in China mainly, if they, especially if they want to continue to study at Southeast University, they will come and.
No, because I'm thinking if you're video streaming around the world, in Europe it's 4 o'clock in the morning, in America it's 10 o'clock in the evening. Probably.
I know it's so difficult.
It'll be mostly in China.
Yeah, it's so difficult to find time that fit for all audience all around the world. But what we're doing is, I don't know whether Professor Yuan mentioned to you, and of course it's upon your permission. We're recording this, and then we can share with people who cannot attend live.
If they want, yeah.
Yes, that would be some good thing. Yeah. Still hot? Oh, it's turning a little bit better. We'll start around 2 minutes.
Okay. Just out of your way.
Okay, it's around 10 o'clock, so let's start today's public seminar. So thank you everyone for coming to today's public seminar. This is the 13th public seminar of Urban Lifeline Journal, and we have you as in-person audience, and we have many online of the world. Hopefully, we're just talking about it's not like a good time probably for people in US or Europe, but we will record today's session and they can get access to the recording later today. So today we have a very honored guest, Professor Mirosław Skibniewski. So you probably know him a long time ago as a very distinguished professor in the field of construction engineering and management. He is a professor at University of Maryland, and out of all his great achievements, you probably all read the journal Automation Construction, and he has been the editor-in-chief for decades. So, you know, this is a great honor. We have him today here in person and make a presentation to us around the smart city issues, right? The technology integration and how that create issues and how we can address them. Mainly in US, right? It's context in US, but we also have some examples in Europe, and then we can later discuss and relate that to the similar issues in China. So without further ado, let's welcome Professor Skibniewski. Thank you.
Thank you so much. Thank you very much for a kind introduction. I'm a relative newcomer to the issues of smart city research. My work has been primarily in the past in construction automation and the information technologies for construction. And also last January, an article was published in the engineering journal, published by Elsevier and edited here in China. And I was asked to write an opinion piece on the future, the present and future of smart construction technologies. So I can claim some territory in the smart construction technologies research. However, smart city research is a relatively new expertise for me, and it's a much broader issue. So I'm basing the presentation and the remarks I'm going to make today largely on work that has been conducted with my colleagues in National Institute of Standards and Technology, which is a major research organization and standard setting organization in the United States, and just happens to be located very close to our campus at the University of Maryland. The NIST campus is in Gaithersburg, Maryland. So I've had a long-term affiliation with NIST, and the colleagues at NIST are actually actively pursuing various agendas in relation to smart city research. So as these slides reflect, the footnote on the slides is much of that work should be given to their credit. So that's let me just get started with a big picture as to what is a smart city. A smart city is really an axiological concept, I could say, that really encompasses a number of disparate entities and disparate entities in terms of functionality of a city. Everyone knows what a city is. It's really a collection of cohabitating individuals and families sharing public infrastructure and actually making it work together on a daily basis. So one of the issues that is very important, and this is something that every city is worried about, is mobility, is urban transport. And in fact, the early efforts on how to define a smart city focus primarily on transport because people need to get to work every day, get back home in the evening, and then they have to go shopping, they have to entertain themselves, children have to go to school. All of these issues affect greatly mobility, so internal city transportation. But we also worry about individual elements of this infrastructure. So homes and offices and factories, and so buildings in general. How do we make them smart? How do we make sure that we take full advantage of information automation technologies, for example, for energy management, for lighting management, and so on. Of course, humans get sick and require medical care, so how do we actually ensure that we take full advantage of technologies available to deliver our health services, healthcare services, in a smart way that is supported by information technologies. So buildings in general can also be thought of as smart by taking full advantage of information automation technologies. Not just energy management, but also vertical transportation in buildings, so lifts that run up and down in high-rise buildings, also in seismic zones, and there is no shortage of those here in China. We have to worry about making these buildings resilient to earthquakes, but also to fires, to floods, and so on. Right, so we have a number of other issues that need to be tackled. So, for example, commerce. How do we ensure smart retail operations? And if, in fact, China is the world leader in supply chain, smart supply chains, and very rapid delivery of goods and services to end customers. I know that if you use one of these online platforms here in China, Taobao, they can deliver some products to you in as short a time as maybe half an hour, right? They're delivering your lunch food every day or every work day. How do we work smarter in our work environments? How can we develop better tools to ensure better productivity? So management of temperature, lighting in spaces. How do we actually take full advantage of the spaces that exist to avoid space vacancy and utilization of space in smart ways? So these are just some of the examples. The other that very quickly comes to mind, smart management of refuse and garbage collection in cities and disposal of that garbage, recycling efforts inside cities. All of that is a domain of a smart city. All right, so what's the definition of a smart city? Well, there are numerous definitions. The one that is quoted here is by Boyd Cohen. So smart cities use the ICT, so information communication technologies, to be more intelligent and efficient in the use of resources, resulting in cost and energy savings, improved service delivery, and quality of life. All right, so quality of life is the key concept, but also reduced environmental footprint. In other words, the cities doing the least environmental damage as possible, as little as possible. And let's not fool ourselves. Yes, cities are responsible for doing environmental damage, and our job is to ensure that we give something back to the environment as a result. All right, so if you look at the history of the smart city concept, it dates back not that long ago, actually, to 2008. So that was the economic crisis, the worldwide crisis that resulted in a lot of economic calamities. And IBM is actually widely credited for beginning work on smarter cities concept as a smarter planet initiative, because cities in developed countries actually congregate majority of the population. Right now, more than half of China's population actually lives in cities already, but you have some countries in which that percentage is actually even higher. So cities are becoming really the venue for cohabitation, for work, and people commute and stay within the cities. And think about that as well. Even in cities as we know them today, We need the green space and the parks, but 90% of our lives are spent inside buildings. So it's very important as to what we do to buildings and how we actually manage our environment in buildings. So one of the very important issues in smart cities is indoor air, not just outside pollution and outside air, but the air that we breathe 90% of the time that we live, which is inside buildings, right? So that most researchers in recent years haven't really thought of healthy buildings as an important issue in smart cities, but it really is. So where did the concept originate? We can claim that IBM was really the world leader from the start, but the concept originated in Europe. Why? Well, European cities, for historical reasons, have to be dense, and they also have better public transit developed than American cities. Now, cities in China are also dense, historic populations, but because of huge investments in modernization of cities, a lot of the older city quarters were actually razed to the ground and giving space for new developments and new office buildings, new housing estates. So, but that because Chinese cities are so large, much larger than any cities in any other part of the world, then the density of the population in cities is a big issue. So that also gives rise to the importance of sustainability and low carbon solutions. Now, the carbon gas emissions have been touted by politicians as being responsible for global warming, for climate change in general, but it's not just carbon gases. It's sulfur gases, it's nitrogen gases, and actually the most important greenhouse gas is the one that we have little or absolutely no control over in most cases, which is water vapor. Water vapor, the vapors, so water vaporization from oceans, from lakes, from rivers, from grounds in general, soil in general, that of course is also a big factor. So, but that does not diminish the importance of lowering greenhouse gas emissions. Why? Because they're closely coupled with the generation of pollution. And we need to fight pollution at every level that we can, including pollution coming from city operations. It's air pollution, water pollution, and ground pollution. And all of that is closely coupled with greenhouse gas emissions. So this is the true reason why we need lower carbon footprint, why we need to worry about managing greenhouse gas emissions. All right, so why do we need smart cities now? Well, we need to handle the global environment and urbanization problems. As the economies grow throughout the world, the more and more, the higher and higher percentage of the population moves into cities. China has experienced it over the last 3 decades. Some of the countries in Africa and other countries in Southeast Asia and South America are experiencing it now. Last month I was in Bogota, Colombia, in South America. That city is about 20 million people. It's on a large plateau, and there was a program actually on Chinese television this morning that I saw about the water supply for the city like Bogota in Colombia, the capital city, which is so crucial and so dependent on the outside environment. How do we actually protect the outside environment in order to ensure steady supply of water for a city as large as Bogota, Colombia? By the way, that's the only city that I have ever been to in which no building has any heating or air conditioning. Why? Because it's at the high level plateau. It's about 26 to 2800 meters above sea level. So the temperature range is comfortable enough that people don't need any heating or air conditioning. But most cities in the world actually need either or both. Need both heating and air conditioning. So that is, of course, a big factor when it comes to energy consumption in buildings. So climate change is a fact of life. There is no denying that there is climate change. Whether we can actually do anything about it or not, that's an open debate by politicians. A lot of the efforts, some people and even scientists feel that are mostly feel-good exercise. We're doing something about it. But the point is that because climate change is a fact of life, it's undeniable, we have to make our environment in the cities resilient to climate change. So resilience efforts are the ones that we really need to focus on. All right, populations obviously are going to increase rather than decrease in most cities around the world, and resources are going to be depleted at a higher rate everywhere we go. So we need to worry about how to counter that and how to address the problems associated with it. Increasing urbanization also means that more and more territories are being annexed by cities. So surrounding communities, which were not part of cities, need to be annexed in order to accommodate expanding population. That also means that utility services need to be delivered to those expanded areas as well. All right, so we need to overcome restrictions of time and place. We need to worry about economic issues, but also non-monetary values, which are primarily related to the quality of life. So one of the issues that is being tackled, which very quickly is becoming an issue related to smart cities, is walkable neighborhoods. How do we make sure that rather than commuting from one end of a gigantic city like Beijing, for example, where on the outskirts of the city maybe accommodations will be cheaper than in the center of the city, we create these accommodations or workplaces for people near to where they live. Or if we can ensure a public transport, not just metro lines, but maybe alternative modes of transport, that people can quickly deliver themselves to the place where they need to be at work. How do we actually manage telecommuting, and how can we facilitate telecommuting for those professions that can actually be supported by telecommuting? Cutting down on greenhouse gas pollution and cutting down on the time needed to be spent on traveling from point A to B. So these are big issues that smart cities need to tackle as well. All right, so there's a lot of different initiatives within the concept of smart cities, and this is just a shorthand list of them. One is related to utilities, utility delivery. So what is that? Well, it's delivering electricity, delivering gas, natural gas for either heating or cooking purposes. It's delivering water, of course. It's disposing of sewage. All of these issues that are related to our daily life needs and the needs of our workspaces as well. So there are a number of information technologies that are available for the solution of the existing problems. Creating intelligent networks for utility distributions, smart metering. So in other words, being able to provide doses of these utilities that would not overwhelm or bring to the point of breakage the utility delivery systems. So for example, during the times of peak demand for electricity because of air conditioning, during a hot summer day, there are cycling alternatives that allow certain air conditioners to be turned off or operating at a lower level of energy consumption in order to prevent the overloading of the electrical grid. All right, many utility companies are doing that. In fact, the place where I live in the state of Maryland in the U.S. actually is doing that, has been doing that for several years, and they actually offer certain incentives to subscribers to actually participate in those cycling events. We can also utilize information communication technologies for demand planning. Assuming a certain number of hot days in our weather patterns, we can plan for certain levels of demand, and that can be also done using smart routines that can be generated for those purposes. We can also do a better job on operating controls, on water management, of course, as well. So rationing water in dire times of need or there is a shortage of water, but at the same time taking a smart approach to the overall resource management with respect to water. And last but not least, on smart utilities, wastewater treatment. What kinds of technologies are we going to use that are most efficient, less polluting in terms of environmental pollution, and also utilize the least amounts of energy. The issue that comes with utilities is also related to construction and refurbishment of existing utility lines. There are companies in the United States, and I believe also in China, that utilize robotics for relining utility or especially water pipes. Roughly 40% of drinkable water, potable water, is lost due to water leakage in cities. So the cost of delivering water utilities is rising dramatically. I just looked at my water bill yesterday that came in the mail, and it rose with the same usage by almost 90% in the last year. And that is becoming a fiscal emergency for a lot of households that actually rely on very tight budgets. So we need to do our utmost to lower the cost of delivering some of these services that appear to be wasteful because of crumbling infrastructure. So definitely inside cities, and most of these utilities are poorly documented. So we don't have the exact information as to where those leakages are appearing. And any sensing devices, sensing technologies that can be implemented for that purpose are extremely important. And in fact, this is probably the lowest hanging fruit for the payoff of automation and communication technologies that can improve that situation. Then we have smart health. We don't have the time to discuss each of those initiatives in detail, but smart health is also very important because of shortage of doctors, because of shortage of hospital beds. I know the health delivery system in China is vastly different from that of the United States. U.S. operates a vast network of outpatient clinics that are separate from hospitals, whereas most of the patients here in China, as I understand, even with the slightest problem, maybe with a minor cold, they have to go to a hospital doctor to get some kind of treatment. This is practically never done in the U.S. And in most European countries, you have these outpatient clinics. So the solutions that are required in different countries and different cities would differ depending on the health delivery system. Nevertheless, smart solutions are very much called for. So how do you employ and how do you actually expand the network of televisits to doctors' offices when no physical contact with the doctor or with the nurse is necessary in order to provide the healthcare service that the patient needs? So remote healthcare is becoming a trend in many countries, including the United States. When I call my doctor and I want to get some doctor's advice, the first question that is asked of me, do you need to be physically present in the room with the doctor, or will the telemeeting be sufficient enough for your needs? And you can express your preference, and ultimately the decision is to the doctor as to whether he or she needs to see you in person or whether that meeting can take place online. All right. Then there's a host of issues related to public services, tax administration, for example, citizen services, issuing IDs, managing vehicle registrations, whether electric or traditional vehicle, emission monitoring from vehicles. All these services, actually smart emergency response, all of those public services can be improved with the use of information and communication technologies that are available to us right now. Financial management, so budget management in cities, delivery of financial services to citizens, banking, all of that is also part of smart city research. And I mentioned in passing smart buildings, energy usage optimization in buildings, but it's also asset management and facility management. All the repairs that are required inside buildings, how do we streamline these processes to make sure that we make the best use of the limited resources available in any city, by any developer or any housing estate, for example, that manages sometimes hundreds of buildings for the same entity. So all of that financial services can be greatly improved with the use of enterprise resource planning system deployments, for example, that a lot of organizations are already familiar with. All right. And as I mentioned earlier, transportation was really the first aspect that was tackled as part of the smart city. So intelligent transportation is a very important issue. I know here at Southeast University you have a separate school of transportation, which is separate from civil engineering. This is such an important issue. So a lot of these people are specialists in various aspects of intelligent transportation. Smart public transportation, for example, calls for flexible delivery of services during the times and in locations where there is a surge in demand for these services, and perhaps diminished resources for areas and times where the demand may be much less intense. So smart public transportation is really a crucial issue for a lot of cities around the world, and especially here in China, where you have so many cities with multi-million populations. All right, so the city of Nanjing, I understand, it's just under 10 million people, right? It's about 9 million people. But you have much larger cities in China, and in fact around the world, that are even more intense in terms of their dire need for smart public transportation. Fare management in cities also is an important issue when it comes to better projection of revenue needs for, let's say, metro systems in a city. In some cities, actually, it costs exactly the same whether you travel an entire metro line from the beginning to end, or whether you just go from one station to another to the next station. But a lot of cities actually have introduced these smart fare management systems that allow the collection of a lesser fee on a shorter route as opposed to a longer route. Parking issues in cities are, of course, notorious. A lot of problems with parking and ever diminishing space for parking, and providing incentives and disincentives to park closer to the city center for a variety of reasons. Pollution is just being one of them, but traffic management, all of that is also a domain of smart city research and smart city solutions. All right, so that's where we are when it comes to vertical initiatives, but what is it that we need to do in order, for example, to address them in more concrete terms. So transportation technologies being the first issue that has been tackled. If we can take advantage of disparate technologies that exist for transportation purposes, we can deliver some revolutionized solutions. Not only in being able to deliver a passenger faster from one location to another to his or her destination, but also do it safely. Safety of transportation safety is a huge issue because of notoriety of accidents. But at the same time, as we want to increase safety to eliminate any accidents, we also want to reduce cost and environmental impacts. Okay, we cannot compromise on safety, but we can compromise on cost, of course. Safety must be delivered at all cost. We cannot compromise safety. But how do we reduce cost and reduce environmental impact without compromising safety is an important optimization issue. A lot of different models exist for addressing that problem, but remember that the model by definition is always simplification of reality. So we need to make sure that these models are as reflective of reality as they possibly can be. So we have a variety of technologies available for our purpose. We have automation, we have big data technologies that right now with the sensor systems that we have, we can collect more data than we can possibly use. We have vast repositories of data that we frankly don't know exactly what to do with. And a lot of that data actually has a lot of different uses for demand analysis and forecasting in transportation being one of them, but also for managing safety and security of inhabitants in cities. So where do people move most and from what location to what location can become really a very valuable piece of information to possess, but it's also information that needs to be kept secure. Why? Because sometimes bad actors like terrorists, they're interested in that information as well. If they want to inflict the maximum damage, for example, on the city population, they will explode that dirty bomb in the place and the time where they can secure the largest number of victims. And this is something that security services need to be fully aware of, how to counter those malicious actors and how to make sure that sensitive data does not get into irresponsible hands and cannot be used for malicious purposes. So data security is also extremely important in cities. All right, so we have lots of technologies for data collection and management of sets of data. We have Industry 4.0, Construction 4.0, Cities 4.0 rely on the Internet of Things technologies. What is that? I'm sure many of you are familiar with it. It's really sensors collecting disparate types of data in different formats, able to exchange that data, fuse that data, and actually generate information from that data that can be of use to end users, city managers and individual organizations, and in fact citizens themselves. Machine learning has been widely used to infer information from data right now. We have technology for connected vehicles, right, where fleets of vehicles can be monitored in real time. And the vehicles themselves can have access to real-time information on traffic, on weather, you name it. I come from the university that is the place where the founder of Google Corporation graduated from the University of Maryland. Sergey Brin has a degree in mathematics, and he later went from Maryland, went to Stanford to get his PhD. He never actually completed his PhD because he started the company with his partner. And the rest is history. But Google has been a pioneer as a company in collecting satellite data related to traffic and actually creating these traffic maps in real time for cities. And I know you have Chinese equivalents in China for that purpose, and you have a tremendous ability to actually manage traffic and to monitor, not just monitor, but also manage traffic in intelligent ways. That can also be a tremendous tool in ascertaining demand, future demand for transportation services in a number of ways, and that is already taking place. So all these technologies may lead to safety improvements, to reduce congestions, reduced emissions, improved access to jobs and services, and of course we want that. Who is also interested in improved access? Commercial entities. So obviously, department stores want to make sure that if the customers are to be attracted to their shops for commercial purposes, they want to make sure that the customers can actually get there. If they're getting there by car, they have enough space to park, right? So underground parking is just one way of thinking of solutions. They need to be located in places where there's easy access to public transportation as well. So all of that is very important also from commercial standpoint. All right, so, but smart cities are, of course, a lot more than just traffic. And so there is this vision consisting of numerous elements that are related to technologies that are available, that are much more expansive than just traffic itself. So urban automation is one of them. So being able to deliver services in an automatic fashion. So mobility services and choices that are user-focused, business models and partnering, public-private partnerships are also important in delivering smart services in cities. So government entities and private businesses working together to achieve that. Then you have issues such as connected vehicles that I mentioned. So vehicles that can, not just autonomous vehicles that drive themselves, but also hybrid vehicles that can operate sometimes in an autonomous mode and sometimes in a conventional mode. You have urban analytics that delivers real-time data on where people are, what they're doing, where they're traveling to, anticipating their needs within the next hour, within the next day, or within the next week, and anticipating the demand and forecasting of various utility services, for example. So creating smart grids. It's very important, for example, for the distribution of locations of recharging stations of electric vehicles. All of that. Smart land use, very important for a lot of cities. A lot of good examples from places like Hong Kong or Singapore that have set aside certain amounts of land that is off limits when it comes to urban development. You're not supposed to build on that land. In Hong Kong, for example, 90% of the land, I don't know if everybody realizes that, is actually parks and pathways, and it's pristine area. Hong Kong is not just the largest concentration of high-rise buildings in the world, which it is, but 90% of the land, or right now actually slightly less than 90%, is actually not built up. So how do you manage that land? What land can be released for development? And then we have to worry about what do we give back to the environment to compensate for the damage that development will do to the environment. So delivery of services and logistics. If you have that delivery truck bringing your goods and services to you. Where is it supposed to park? What are the environmental implications of creating certain routes for these services? All of that is important. All right, so in the US, the efforts actually have been split into two phases. There's a phase 1 and a phase 2. And these are annual grants right now. Cities are selected based on the competition of actually what they propose to include in their smart city services. There are financial packages that are available for these cities to deliver these services. They're not very large. $100,000 doesn't take you very far, but it's definitely a good start to develop these services, the concepts for these services, and then have an uptake of either commercial entities or city governments to actually set aside additional funding to deliver these initiatives. So every June, so in mid-year, finalists are selected from the competition, and there are other organizations that also contribute money to these efforts. So Department of Transportation at the federal government level actually also gives $40 million for that purpose, and then individual companies are also contributing to that effort because they're interested in developing these smart city services in furtherance of the expansion of their own business. So they see it as an investment in their own business if they can participate in that effort. So let's see. We only have 1 hour, right?
Yeah, but you can.
So I want to just quickly erase through some other efforts that are being promulgated in the U.S. So there is also a notion that the smart city doesn't necessarily have to be a very large city. So in the U.S., a smart city is defined, an ideal smart city as being as having a population under million inhabitants, right? Which is not often the case in China. Most of the cities are actually multi-million cities, right? So, but in the U.S. has much lesser population density because the population of the U.S. is about 5 times less than of China, with the same kind of land mass. So you have a smart city between 200,000 to 850,000 inhabitants, right? 200,000 people wouldn't even qualify as a medium-sized city in China. It would be a tiny, very small town. But there, for historical reasons, not just the U.S. but also Europe, a 200,000 population city can actually have quite a dense population because of the architecture of the city. So that kind of environment where you have dense population and a relatively small population by Chinese standards is an environment that's conducive to demonstrating advanced technologies. That doesn't mean that in larger cities you cannot do that, but maybe you would encounter more difficulties if that's the case. All right, you would need to have an existing transportation system in the city in order to demonstrate the utility of smart city solutions. Unfortunately, in the U.S., there is a lot of cities that do not have an extensive public transportation systems. I don't know if any of you have traveled to Houston, Texas, or Dallas, but these are the two examples of cities where you don't have much of a public transportation system. My first city in the U.S. where I lived, Pittsburgh, in the early 1980s, didn't have an extensive public transportation system. Now it does have a much more extensive system, but there are still a number of cities in the Midwest and the west of the United States where that's not the case. And believe it or not, with me living in the suburbs of Washington, D.C., I don't have any public transportation option to get to work from where I live. I have to drive a car, right? But that's unfortunate, but that's unfortunate. That car-centered structure has made a tremendous impact on the way that cities in the United States have developed. Whereas cities in Europe and in China did not start with that premise that every citizen would drive his or her own car. And that's completely a different paradigm. All right, so the ideal intelligent or smart city would have to express a commitment to integrating transportation services with the sharing economy. What does that mean? Well, if we have to drive a vehicle, we don't have to do it alone. We can share it with other people. And hence the rise of car services like Zipcar. I don't know if you heard the name of that company, that allows you to pick up a vehicle at the location where it's convenient for you and drop it off at a location that's also convenient for you, but it may also be convenient for the next user of the same vehicle, right? So the younger generation, the so-called millennials and younger, are quite fond of that option. And I know in a number of Chinese cities you have these services, not just for bicycles and scooters, but you also have them for cars. So China, in fact, has been in the forefront of the implementation of these technologies, whereas in other parts of the world that's not necessarily the case. But it's definitely an element of a smart solution for a city that grapples with a transportation problem. All right, so an ideal smart city would also make a commitment to making certain data open, discoverable, and usable by the public so that it can fuel innovation and entrepreneurship. But at the same time, keep in mind that some data that is sensitive, that cannot be shared with the public for security purposes, has to be kept confidential. The aggregate data. But the data that would make life of these citizens easier, where a citizen can actually readily access information where that next vehicle is available and how soon can I have it, and where can I drive it, and what are the cost options, because an intelligent system can actually dictate as to how much it'll cost to drive this vehicle from point A to point B versus from point A to point C. So then the user can make his or her choice as to what is the most viable option in terms of the cost issue. All right, so committed leadership and capacity to carry out the delivery of these services throughout the entire period of performance is also very important. So the cooperation of city authorities, decision makers with respect to the various utilities that are being delivered, various functionalities, and cooperation of the general public, so inhabitants of that city, and also visitors to that city, is important for the smart city concept to work. Right? There are a number of interesting challenges that also emerge. There is a concept of pivotal points of interoperability that enable agreeing on some things but not on everything. There will be always conflicting interests between different entities in a city. So you have to realize that that certain frameworks that are being created don't necessarily would be an ideal solution for everyone, but it'll be a shared solution that will be sort of a happy medium between the options that individual decision makers and users would consider ideal. All right, so there is still a lot of research and development necessary in order to explain exactly what these concepts will mean and how they would work out in practice. The framework that National Institute of Standards and Technology has established is dubbed as the algebra of the Internet of Things. So by algebra, we really mean the definition of the operations that we can perform on data and the sensors themselves that are part of the Internet of Things concept. What it means for open source systems development is not entirely clear at this point. So a lot of research studies on entrepreneurship in smart cities will have to be pursued, but these are topics for active research that can be pursued both in the United States as well as China or any other area in the world that is interested in actually promulgating these smart city services and making sure that they have a practical meaning in their cities. There is a number of initiatives, including the one that we have with NIST at the University of Maryland. We distill a common set of architectural features from architectural efforts and city stakeholders. So we look at the way that cities are being designed and redesigned and reactivated or in a variety of scenarios. So for example, right now we're pursuing a concept of defining the smart city development in the post-COVID-19 era. That has tremendously impacted the way that cities operate in the United States. Why is that important? Well, in the capital city of the U.S., such as Washington, the vacancy rate of office buildings has dramatically shot up during the COVID era because the federal government in the U.S., as well as many corporations, have decided that the only way to operate their services is in a remote fashion. So they allowed their workers to stay back at home and operate from their home online. This is where companies such as Zoom have seen a tremendous increase in the demand for their services, and they have really flourished. And a lot of people who didn't believe in remote work and how productive it can be prior to COVID-19 have become converts and believers. And honestly, nothing has come back to normal after COVID-19 pandemic has been already diminished. In fact, many corporations have decided that some of the workers that they employ may stay at home and actually operate from their home location. Why is that important? That allows them to cut down on the cost of rental of office space, which is very expensive. But it led to the point that the vacancy rate in cities like Washington, D.C. has reached the point of about 40%. So almost half of all the office space remains empty, so that the owners of these office spaces are really desperate to convert that space into something else. So at the same time, we have a shortage of housing in many cities throughout the United States. And the big challenge is, how do you convert vacant office space into apartments, into housing? It's not easy. Why? Different reasons, but think of it that way. And this has nothing to do with smart city solution, but it has to be addressed by smart architecture and smart design. In an office space, you have a suite of offices next to each other, and you have two washrooms, one for men on this end of the corridor and one for women on the other. And nothing in between. You don't have any bathroom spaces in between. Now, if you want to convert that space to individual apartments, every apartment needs to have its own plumbing. So how do you, it's not cheap. It's actually quite expensive to put all that plumbing up and down and completely redesign the whole water delivery and sewage disposal system inside buildings, right? Let alone just reconfiguring the space itself. But the delivery of these utilities and rewiring the office space for apartment use is very costly and time consuming, right? So what do you do with that, and are there any alternatives to that? How can you actually redesign space to be more flexible? And people are not going to share, the individual families are not going to share bathroom space with another family. This is not likely to happen. Although in dire in emergency needs, of course, that can be done, but not on a daily basis. So that's one of the challenges that the cities are grappling with. And that has to do with also, if you are going to convert that to residential space, if it's supposed to be just for family, not for single people as workers, what about schools for these children that are going to live in those families? And what about entertainment services? What about transportation? Whatever else, all of that needs to be part of this smart city development, redevelopment concept. So ancient cities in Europe and in China, they were walkable. There is this concept of a walkable city where everything that you need to get to on a daily basis is within a 15-minute walking distance, right? Including shopping. And so you can bring your groceries to your house by walking in 15 minutes, right? A lot of challenges because even in the 1980s, there were a lot of department stores in city centers in the United States. Much of that space has been converted to other use because people just don't go walking into a store straight from their office and get into their car. They get into a car and drive to the suburbs, and all these shopping centers are in the suburbs. So how do you reconfigure that space inside the city to meet the environmental goals, to meet the walkability goals? It's a very complex system, every city. So another issue is, of course, delivery of health services, emergency services. What if somebody gets a heart attack? How quickly you can get an ambulance to that person to deliver him or her to a hospital? All of that is very important. So these pivotal points of interoperability are pretty challenging. So one of the observations is that you cannot standardize solutions for every city because you will freeze out innovation, right? So there is no such thing as one-size-fits-all solutions for every city. So these need to be customized solutions, all right? But on the other hand, if you standardize nothing, everything is customizable, then you get non-interoperable clusters that cannot be easily integrated. So you have to look for a happy medium, right? So that's a huge issue. So the principle of pivotal points of interoperability is to find consensus, standardized interfaces that deal with composition of cyber-physical systems without concerning innovation. So the effort should be put on these interfaces between standardized, between customized solutions and standardized interfaces, right? So customize the solutions in a modular fashion, and at the same time standardized interfaces. So these interfaces can actually be replicated in different cities across the country and across the world. All right. And there's a lot of effort that can be activated as a result of that, because these individualized solutions for the functional modules can generate a lot of independent, innovative technology solutions. So that's where small technology developers as well as larger vendors can play a vital role in collaborating together on the solutions. All right, so we need to worry about how these solutions will affect interoperability. So that's why these standardized interfaces are so important. So the pivotal points of interoperability can become magnets for innovation of individualized solutions. All right, the hour has already passed, and there is a lot of material, a lot of issues to cover. I just want to leave it at that we are at the point of grappling with the idea that it's not going to be one-size-fits-all solutions with even with the technologies that we have today. What's a big disruptor in the development of functionalities of these technologies are large language models and large image models that will probably speed up a lot of the developments based on data repositories that we already have. But the overall operational framework that NIST is proposing is to look at a city, a smart city, as a system of systems, right? And each individual component of a smart city can be viewed as a system. And within that system, you have individual devices that are based on the Internet of Things concept. They can talk to one another, exchange data, generate information, and the generation of information is most likely going to happen with the use of LLMs as well as LVMs, large vision models. And that's where this effort is heading, and to what extent that becomes a reality probably remains to be seen. So let me just maybe stop and see if there are any questions from the audience. I'd be happy to address any questions.
Thank you so much, first of all, Professor Mirosław J for the great presentation, very front, cutting-edge research on smart cities, all the concepts. And let's see any questions from our students. Anything, okay? Yeah.
Yes.
Thank you for the excellent presentation. And I have two questions to communicate with you. The first is you mentioned the challenges in the build smart cities, and I wondered how do you combine the smart city with urban spatial planning, or is there any relationship between the smart city with the urban planning?
That's it.
And another question is how to ensure you mentioned the data resource is very important in building the smart city. I wonder how to ensure the data safety in the smart city.
Right. These are two very important questions. Of course, urban planners work on development of urban spaces and the functionality of these spaces to meet the demand of the users of these spaces. They cannot be decoupled from the efforts related to smart cities. So this is the new level of expertise that city planners, urban planners must develop in order to do an adequate job in their efforts to redesign urban spaces. If they do it in isolation from the efforts of specialists in smart cities, efforts in technology, that effort will be wasted because it will not meet the real needs of its end users, of the constituent groups that will rely on the smart city technologies. So there has to be a lot of dialogue, a lot of communication between urban design professionals and the smart city technology professionals. They need to communicate. One example of that is if you're developing a space that's supposed to be an entertainment center for the city, you have to address the issue of electronic communications. How many fiber optic lines will have to lead to that location? Where exactly, how are you going to house these fiber optic lines? Where do you envision the points of access to these lines to be able to install them and repair them and to maintain them? And you would have to work with architects also of individual buildings in that space in order to facilitate the needs of the technology as well. So a lot of urban spaces will be developed using new construction technologies. Yesterday when we had this seminar, I mentioned 3D printing, right? We talked about 3D printing. A lot of new urban space will include buildings and other objects that are 3D printed from various materials. So how does that correspond with the needs of, developing smart city services and smart functionalities of the city? So for every design solution, you'll have a set of questions that need to be answered, and part of the answer will be provided by smart city developers. Okay, so that's this question, and the question of data is also hugely important, because data will come from a variety of sources. Data will come from the Internet of Things, sensor systems. Data will come, for example, traffic data, congestion data will come from satellite system operators. Either in the US we have GPS, in Europe they have GNSS, in China you have the equivalent of that system, and so that data needs to be fused with data coming directly from facilities located inside the city itself. So data interoperability and data fusion will be a very important area of future development, application development. The technologies are in place, but the question how you combine these technologies, how you integrate them for a specific design that corresponds to the need of individual city is a crucial engineering issue. It's a data engineering issue. But data security and data safety, that's a tremendous problem that needs to be addressed. Some of this data inside the city will be on a need-to-know basis, and other data will have to be publicly available to end users in order to make these systems functional, right? So there has to be a carefully crafted data access policy to make sure that the public is safe, that proprietary data is also kept confidential, but at the same time that it doesn't hamper functionality of the end purpose of that data. It's not an easy problem to solve. It's a multifaceted problem that is riddled with a lot of conflicting objectives. So it's really a complex optimization problem.
Great. Any other question? We'll take one more question, okay? Take this opportunity. Any question about smart city or any other something online, right? I
Yeah,
heard
if there's
something
someone
online.
online.
Yeah.
Okay.
Let's
see.
see.
Maybe if someone wants to ask a question
yeah,
in
let me-
Chinese.
We cannot. Just wait a sec. Let me make sure we can hear you. The sound is not very. Can you try it now?
Okay, can everyone hear me?
Yes.
Yes.
Okay, so okay, thanks for a very nice presentation. So my name is Zichang Chen. I'm from University of Missouri, Kansas City. So I think I want to have a quick comment. Also want to get your vision about this. So I know, I think probably fair to say the notion of smart city peaks, and people talk about it a little bit less today because there are new notion, new concept coming. One would be digital twinning. But of course, right, there are other technology coming. When you talk about Internet of Things, right? So it's more of like hardcore technology, sensors, which collect data, and then software process data. But when we think about today's technology landscape, we have generative AI, which has more reach to people. Like people use generative AI, use ChatGPT, using other things, right? So people can get response in like near real time. So basically, people are more involved. So what's your vision? So what's your, let's say, projection or forecast about how this digital twin concept or smart city concept all come together in next 5 years?
Yeah. Well, you touched on a very important problem on how will the latest explosion in the functionality of AI-based models affect the operation of a smart city. Well, there will be improved access by individual users to vast repositories of data and information through these newly emerging tools. But at the same time, we cannot lose sight of the fact that a city will have to operate as a complex system or as a system of systems, right? So individual end users and inhabitants and residents of the city and workers in the city will operate within that system of systems. So even with their access to information that is vastly improved over what we had available even a year or 2 years ago, they will still face the same physical constraints. They will still face the same functional constraints as to what they can do in terms of resources available to them, spatial resources, time resources, and physical resources like utilities. So all of them will have to be governed by solutions promulgated on individual systems, so individual functional components of the city, and the city itself as a system of systems. So yes, these tools will be a big help in the development of the solutions and delivering of the solutions, but they themselves will not be a solution in itself.
Yeah, I think, in a way, complexity, right, is still there, remains, or even bigger, in greater.
Right.
Yeah.
So you said you're at the University of Missouri?
Yeah, I'm from University of Missouri, Kansas City. I'm so
Okay, excellent.
yes, I'm
So it's
probably
very,
the same
very
time
late
zone.
in the evening for you.
Oh yeah, Friday night I got nothing to do.
Okay.
Yeah, but thanks for presentation. Yeah,
Thank you for listening in.
yeah, thank you.
Okay. Okay, so it's already like 11:15. Let's give another round of applause to Professor Mirosław Skibniewski for this great presentation. Okay.
Thank you very much.
Well, Professor Mirosław Skibniewski is very supportive to our School of Civil Engineering at Southeastern University. Like yesterday, he just gave a presentation to summer school. Some of you are already there. And he's also the advisor to our Urban Lifeline journal. So this is journal, you may know this is funded by University of Southeastern University and Springer Nature. I'm sure we're also brainstorming some more collaboration opportunities, like some short-term courses. So if you have anything, I'm sure he will be very happy to answer your questions offline after this presentation. So just reach out to him. He has you can find his contact information online or get access to reach out to him through us. Okay. Thank you. Thank you for attending today's presentation. And if you have anything else, you can communicate with Professor Skibniewski after the presentation. Okay.
Yes,
Thank you.
Thank you.
Thank you so much.
Oh,
It's
my pleasure.
Great. And you can see we have people overseas
That's
in
good.
the US to attend. And actually, Professor Zhi Chen is an executive editor of Urban Lifeline. So he's also an alumni of Southeastern University. So he's
Which professor?
Professor Zhi Chen, who just asked you a question about AI.
I see.
He's
Okay.
one of the executive editor of his journal. Yeah.
Excellent.
So probably next time for our conference you can meet him in person. Next year we'll have that in Nanjing, and then the year after will be Australia. So hopefully he can. Actually, he was in Japan this year.
In Japan?
In Japan, our conference is in Japan this year.
Yeah, I remember that meeting of the editorial board was like at 2 o'clock in the
Yeah.
so it was middle of the night.
Yeah, it's not
And I think I
feasible
was-
for you to attend that.
I
Yeah.
was somewhere. I was in Europe, I think.
Anyway, yeah,
Okay,
I think Professor Yuan's student is going to take you to Yuan to visit and for lunch, right?
Okay.
They communicate that. You were taking for lunch and then for some sightseeing in the afternoon.
Are you joining us for lunch?
No, unfortunately, we have some other meeting for the summer school in the afternoon.
I see, okay.
Yeah, I was hoping to go there because that should be a nice place, right? I've never been there, the Yuanbo. Yeah. So you two will go, and the other people will go?
With Professor Yuan.
Oh, Professor Yuan will go as well. Okay.
And the lunch we are together.
Yeah.
Afternoon come.
Yeah. Oh, he won't join lunch. Where
no,
he?
No.
Okay.
原来我们中午来的上。
Okay. So you are leaving now?
Yeah.
Okay. I'll work you there.
Okay, thank you.
I will tell a moment I call the taxi.
Okay. Yeah.
Okay. How is the summer school going?
It's great.
Today's the last day?
Today is the last day, so we have the graduation ceremony
I see.
tonight at 8, and then in the afternoon we
Are
still have some
students
meetings.
taking any exams or no? Or is it just...
Actually, there are some exams.